So I said in the last video that there was one more piece about ellipses, one more important vocab piece, but it's also an important graphical piece. So it's not just the name. It's a really important property, and well, not just really important, actually really cool, in my opinion, about ellipses. So what I've done for this demonstration is I've taken a piece of string and I've just taped it to this piece of paper here. I tried to find a Desmos app, but I couldn't really find one that did what I wanted to do. So I have a piece of paper here. I have my piece of string taped to it. So pretend that these 2 points where the string is exiting the tape, one there and one there, pretend those are 2 points on your coordinate axes, okay? What I'm going to do is I'm going to take my pencil or my pen and I'm going to pull the string tight, not super tight, but just put tension on it, and I'm going to trace around and see what happens. Oops. Oh, it should work. Whack. This will work with my pen. Stand by. Okay, let's try this. So I'm going to take my pen here. It's a little bit better. Keeps kind of pulling off, but you can kind of see what's happening. And I didn't cut it tight enough, or sorry, I made my tape, or I put my string in a weird position, but you can kind of see what's happening is that I'm getting the top half of an ellipse. Let me try again one way here on this side. That's not so bad. Right there. It's not going to be perfect, unfortunately, but you can imagine if I had done this on the computer, it would be much better. I'm going to try it this way. Oops. Like so. And you can imagine that if I kept going, then it would trace around this way as well. So hopefully that demonstration did its job. And so what happened? Well, this is indeed an ellipse. It doesn't just look like one, it actually is. So what happened? Well, notice here, whether I'm at this point right here, the length of the string doesn't change. Like the total length of the string that's in between these 2 points is the same here as it is, say, down here or over here or anywhere else. And so what we can say is if I draw this right here, these two, this distance and this distance total is the same because it's the same piece of string. And so that's another way to define an ellipse. So I could define an ellipse as such. Oops. An ellipse is the set of all points an ellipse is a set of all points such that the sum of the distances from, let's say, from two foci or foci or foci or foci, like I don't know how that word is pronounced, and I've been talking about this stuff for a long time. There is a correct way to pronounce it. I don't know what it is, and I don't care what they are. The two foci are these 2 points. So that total sum, so that total distance, which is again this distance plus this distance, is constant. So if you just give me 2 foci and you tell me how long this total length is, I could draw an ellipse because I could just take that piece of string and then draw it around. Okay, so let's think about this. How would I actually figure out where these 2 foci are? So first off, I think it's fair and I think it's pretty clear that we can accept that the foci are, if this is the center, equidistant along from the center. I think you can also see from this picture that the foci are along the major axis. So again, the major axis is the longer of the two. So this right here, draw that. That's the major axis. And this perpendicular to that, out there, not very good, but that is the minor axis. The distance from the center to either the foci, we call that the focal length, or the focal distance. So the question is, what is that? So to do that, we actually have all the tools. So let's pretend that this string, and I'm going to draw this, so actually let me tape that down. Okay, it's not perfect, but pretend that this point is right there on the ellipse. Okay, so let's call these two distances, we'll call that D1 and D2, pretend. Okay, so D1 is the point from the distance from this point on the ellipse to one focus, and D2 is the distance from that point to the other focus. Now we know that D1 plus D2 equals a constant, some number, and it's always the same. The question is, what is that? Well, notice, if I bring the point all the way down here, and now I'm kind of wishing I didn't tape it down. If I bring it all the way down here, what is that distance? Well, notice, this distance together is already the semi-major axis. So let's actually give some labels here. Let's define the semi-major axis as 2a, where a is, in this case, the x radius. So let's define some stuff. X radius equals a, and in this case the y radius equals b. So in this case the x radius is also the major, running out of pens here, major, or semi-major rather, and the y radius is the semi-minor axis. Minor. Okay. So if we pretend that we're looking at this point right here, well, D1 would actually be this right here, and I'm going to use another pen actually. D1 would be right here. That would be D1. But also notice that D2, well, that would be from this focus to this point right here. And so D2 would be right here. D2. Now, what is D2 and D1 together? Again, that's going to be some constant, but look here. Can I just take this D1 distance right here? Isn't that the same as this point right here? And so this distance together is D1. And so D1 plus D2, together is just the entire major axis. And so that must be equal to 2a. And so let's see, D1 plus D2 equals 2a. We're almost there, because now take a look at this triangle. And I apologize for using the same picture. I just don't want to mush two videos together from my, from this camera plus my screenshot from my computer. Now pretend that I'm looking at the point that is directly above the center here. Or in this case, it would be perpendicular to whatever the major axis is. So if this is sideways, then it would go this way. But just looking at this one as if our ellipse is more horizontal. Look here. If I draw now from that point up there on the ellipse to the foci, whatever you want to say it, then in this case D1 and D2 are equal to each other. So I have D1, D2 are equal to each other. That would mean that D1 is A and so is D2, because the total together they make 2A, right? So these would be congruent triangles, and you can confirm that with some geometry, right? Because the focal distances should be the same. This is perpendicular, and they share this side, so they'd be congruent by side angle side. Anyway, or leg right triangles. Anyway, so what is this? Well, look here. This is the focal distance. So I'm going to call the focal distance C. Call it C. So this is C. Okay. And how much is this? Well, look at here. This is the y radius, the minor or the semi-minor axis, in other words. So this is B from over here. So if I use this right triangles, and I'm going to zoom out here and go down here. So that's A, that's B, and that's C. With a little Pythagorean theorem, once again, we have, well, again, we're looking for C. That's what we're looking for. So C is equal to the square root of A squared minus B squared. That is the focal length. Focal length. Let's just remind ourselves what A and B are. So C is the focal length. A, in this case, was the x radius. So what's so special about the x radius? The special thing about the x radius in this scenario is that it is the semi-major axis, depending on whether the ellipse is more horizontal or more vertical. Again, this is just the larger of the two radii. So another way to write this is, and I'll put that down here, that the focal length is equal to the square root of the semi-major axis, or just a axis AX, squared minus the semi-minor axis squared. This should also make sense because if you did the minor versus the minor minus the major, you would have a negative number here, and then you wouldn't be able to take the square root of a negative number. So you really couldn't mess this up. Just remember here that the major is the larger of the two radii, and the minor is the smaller. In the next example, or in the next video rather, we will do an example of this. So I'll just give you a random equation. We will graph it, and then also find the foci.